Okay, so welcome to the week 6 live session. And so in week 6 there is just 1 second. Okay, so good evening everyone. So we'll start with the today's session. Just a second, I just so today in week 6 there is no assign there was no programming assignment, there is only quiz. So so before going to the week 6, in some many people on the last class asked me to show the solution of the week 4 quiz, the number 2 second quiz, no sorry, second assignment, the one hop assignment. So first I will solve that and then we'll go for the week 6 quiz. Okay, so let's see the question first in one hop. So in the one hop, um, okay, an airline has assigned each city that it serves a unique numeric code. It has collected all the information about all the direct flights that it operates and represents as list of pairs ij, where I is the code of the starting city and j is the code of the destination. It now wants to compute all the pairs of cities connected by one intermediate hop and city. So if city I is connected to city j by one intermediate hop, if there are direct flights from ik and kj for some other city k. Now this line is very important because this is where the actually the solution of the whole code is given. So we have to find a pair of like, sorry, we have to find a pair ik and kj. If that pair is there, then that is our hopping flight, right? The airline is only interested in one of flights between different cities. Pair from, sorry, pair from the II is not useful. Of course, II is not useful. Write a Python function one hop that takes inputs a list of pairs representing direct flights as above, as described above, and returns a list of all pairs ij where I is not equal to j, such that I and j are connected by one hop. Note that it may already be the case that there is a direct flight from I to j. We don't care if there is a direct flight, so long there is an intermediate k with the flight from ik from k to j. The list returned by the function include ij, the input list in the lexicographic order. Okay, so let's see. So the so the idea is like that. Yeah. So the idea it seems first that the code is very difficult, but the idea is very simple. So when we are given a list, in any list we'll have actually a list of say ij, and then j jk, like that. So there are different cities. Okay, now actually the idea is that we have to find pairs between I, where there is ik and kj. Sorry. Ik and k comma j, correct? So these two pairs, if we have any I, so now if we have any common k between I and j, that pair will be connected by a one hop. Okay, so Now if we consider the code or any input of the code, so I have already solved it, so I just one input, if I just take like this, okay, yeah. So this is our one of the input. Now if we consider this as I, this 2 as our I, then 2, then and some city as J, say 3 as J, we have to find something that has 2 K, some K and K3, correct? If that is there, then there is a direct flight. We can have a uh, one of 5 flight between 2 and 3, correct? So like that, okay. Now so let's solve this on that note, okay. So first, our first goal would be, now what is the first our goal would be to make a IJ dictionary, okay. So how we'll do that? So in our input we'll have multiple cities. Now we'll make a list where we'll say from city I there is from J1, J2, sorry, I1, J1, J2, J3, like that flights are there. From city I2 there are like again maybe J4, J5, J6, like that we have different. So we'll make first a dictionary. That is very easy to do. So what we have to do, first we'll define the one hop L. I'm sorry. And we'll make a, so I'll just make a dictionary where is like flights, okay. So flights is a dictionary, and we'll say that okay, for city or for pair, rather, for pair in L. Now for pair in L, for pair in L, now each pair in a L is like 2 3 1 2 3 1, like that. So we'll say that okay, for in a pair in a L, our if pairs first item, that is my source, is not in, sorry, no, not is, just not in flights, okay. If it is not in flights, then we'll say that okay, make a key of pair 0th element, the first element, and and make a list and append pairs 1, okay. So the first we are initiating a pair, initiating a pair list. If it is already there, else if it is already if it is there, then we'll say okay, flights pair 0 dot, because that list is already there now, if it is, so we can append to the list pair 1, okay. So what I am doing is, that's nothing. Here we have a pair. See, from I am just seeing from 2 where all the flights are going, or say from 1, here the from 1 from 2 the flights is only going to sit in 3, as you can see, or 3 and 4. From 1 the flight is going to 2, 2, 2, 3, only 2 3, okay. I'm just I'm making that dictionary pair first. So if I just print flights here, if I just print flights here and show you by just debugging, see, we have a pair. Oh sorry, small mistake happened. This is not a list, this will be just append. So, yeah. So so my key is 1, first key is 1. So from 1, from city 1 flights are going to 2 and 3. From city 2 flights are going to 3 and 4. From city 3 flights are going to 1 and 2, and from 4 it is going to only 1. Like that I am making a list. Okay. Now what I'll do is, now I've returned the flight. I've got my list. Now I have to think of a IJK, right? So we have only, so if, now if I go to here, oh sorry, I'll show you once more. So now if I think this as my I and this as my K, I have to find that some J that has K also in its journey list. Is it clear? Hello? Okay. So I have to, so if this is my I and this one of this is my K, I have to find that if there is any flight from K to some another city J. If I have a flight from, because my here my statement already has written that if I have a pair of IK and KJ, then I will have a hopping flight from I to J. So from this, if one is my I and 2 is my K, I have to find something, the flights that go to from 2 to 3. So if I flight go to 1 to 2 and then 2 to 3, so 1 3 can be my pair, my IJ, because this is I, this is K, this is K, this is J. Okay. So I'll just run now a for loop.
Sir, could you explain line 36 alone?
Sorry?
Could you explain line 36 and 37?
936, 937, I can't understand.
The line 36.
Line, okay, line 36 and line 37.
7. Yes.
Huh. So I want to see that from, say, from the place 2 where all the flights are going, or from place 1 where all the flights are going. I want to make a key value pair of that. Now at 36 I am saying pair 0 means this element. This element is my key, that is from where the flight is going. So flights pair 0. If the key is not there, then okay, make a list and list with element of pair 1. That means at the first time when I'm running, okay, I'll just show you with debugging it. That is the best way to understand. Okay. So when I'm first doing for pair 0, my pair 0 is, my pair is 2 3. Now my pair 0 is not there in my, so 2 is not a key of flights. So what it will do, it will make a key of pair 0, that is 2, and append a list of pair 1, that is from to where the destination basically. Okay, so now I have a key value pair 2 that has a that has a source is 2 and that has a destination comma is 3. When it is already there, next time also it is there, 3 is also not there. Now this time 1 is already there because now pair is 1 3. So what it is doing, it is just appending another destination. So from 1 there is already 2, from destination 2 is already there. If I do, there is, see, there are 2 elements in 1. So from 1 there is, flight is going to 2, flight is also going to 3. Okay, is this clear now?
Okay, yes sir.
Yeah. Okay, now I'll just do my IJK pair. So my first key is my I. So for I in, okay, I have to make another list. Hop. Make an empty list hop where I'll append all my pairs. For I in flight, yeah. For I in flight, if for I in flight, yeah, for K in flights I, because the flight, okay, I have not printed it. Okay, I'll just write the code and I'll explain to you. flights I if k in yeah if k in flights dot keys, correct, uh, then my j is equal to actually 1 second, just a second, let I in flights I, okay, so just again to I'll again do once more. So, so now my flights, so I have to check that for I, that is this one, in flights, my k is now, for flights I is are my
Sir,
k's.
for I it should be flights dot keys, right?
No, it is okay if you, yeah, you can do flights.keys, but when you are iterating through a dictionary, that means you are iterating through its keys. You don't have to specifically mention that flight.keys.
Okay, sir.
Okay. So whenever iterating through a dictionary, it means you are iterating through the keys of a dictionary. Okay, anyway, let me see. For I, this is my I. Now this is my uh, K. Correct? Yeah, yeah. This is my K. Now if okay, yeah. If K is in flights dot keys, then for J, now my J's are sorry, my J's are these. My J's are these. If it is first is 2, so K2, my J's are 3 and 4. So for J's in flight K, if I comma J not if K in flight comma J, yeah, and I comma J not in hop, then what you do, hop dot append I comma J. Let's see what this returns to me. I'll just see what I have written. I have written correctly. Yeah, for k in flights dot I, yeah, fine. Yeah, same thing I have written here also. Oh, one more thing I have to do. Sorry. If I not equal to j, because if I is equal to j, for example, if I just do here, if say 1 and if this k is my 3, then this k is equal to 1 will also come here, right? So I don't want 1 to come. So and ij not enough, so I don't want 2 times ij to be appended, and so hop will append. Let's see, let's debug the code and see. Okay, so now this is my hop. My hop is a empty list. Now for I in flights, so first my I is 2, because my in flights it is I, so first I is equal to 2, because you can see here first I is equal to 2. So flights I, so that is my k. Now so what is flights I now? Let's see what is flights I is a list, correct? Flights I is a list. Okay, so now my I is equal, flights I is equal to 3 and 4. So now I am iterating to 3 and 4. So for now my k is 3. So my I is 2, k is 3. If k is in flights.keys, yes, 3 is there in my flight.keys. So here is my 3. Now flights k again is another list. So if I again write flight K, it's another list. So now I am iterating through the J in flights dot through the way. So first one is 1, so J is equal to 1. So now my ijk is basically 2. So I have a flight, so like now my ijk is what is 213, correct? So if I could show you, my ijk is I is equal to 2, j is equal to 1, k is equal to 3. Now I have a flight like this, 2 to 3 and 3 to 1. So then 2 and 1 can be connected to a hop. So my ij pair is actually, that is a hop, is actually 2 1. So my ij pair is actually 2 and 1, correct? So in between 2 and 1 we will have a hop. Let's see, and it will int object not callable. 1 second. Nothing. Why is this int object not callable? Happening. Hop dot append. Sorry. No, hop dot append. Yeah, I am appending this I and j. Somewhere in line 45 there is some mistake. Hop dot append. Yeah, and hop dot append ig. Correct. Let's see again once more what is happening. So my ijk is now fine. If I not equal to j,
Sir, could it be because it should be j not equal to I? In the previous code, it
doesn't
was
matter,
like this.
doesn't matter. I
Doesn't
not
matter.
equal to j and j not equal to, yeah, because it's the
Because you
problem
are
is happening
iterating
here.
in j, right?
Doesn't matter,
Okay.
doesn't matter. If I am iterating in j or I just want to say I not equal to j means j not equal to I. Let me see. It worked now. I think there was some issue. It worked now. Some other issue. See now. I think what is called? Uh, there I have changed something now. I was calling those. I think somewhere it's got changed. Yeah, it's fine. Code is fine. So now that 2 1 is one of my pairs. What I called you 2 1. 2 1 is in my hop. Okay. And secondly, when now my second J, that is flights K. Again, let's see what is flights K was. My flights K was 1 and 2. My second is 2. Now I and j are equal, so it will not happen. It will not happen. Now it will go back and it will go for the second k. Now my flights I was 3 and 4, so now it will go to 4 and check. Okay, 2 2 4 and j is now 2 1 4. So now it will again okay 2 1 and 4. Okay, it is going back. Then now I'll just proceed it this. Let's see. Okay, I have to print the hop. Oh, done. I say print my hop. Now I have to sort it, right, also. So print sorted hop. I guess I'll leave because I don't need now anymore. 1 2 1 3 1 4. Like that it is there, and so I have just did a equals to sign if it is correct. So here I have just given I have to return it, so return, I just return it. So I just what I have written here, this was the answer that was given in the test case. This was the answer. I'm just checking if my answer is equals to one of equals to the answer. So it should return true. Let's say if it return true, it is returning true. Okay. I have some. There are some other examples also. There are lots of other examples. Okay, I'll just copy this till then and see all the time I'll get true, true, true. Yeah, all the times I'm getting true, that means my code is correct. These are the answers. Okay. So is the one of code is clear now? It's very simple. It's just have to just iterate through dictionaries. Is it clear now?
Yes,
Okay.
sir.
Okay. Okay. So yeah, I think this is one of
Excuse me, sir.
yeah.
Sir, can you provide us the private cases so that we can better, I mean, after the solution is provided, because
Uh,
we can better understand what are the different ways of the thought in doing or
I can't.
in.
I have to ask sir because I don't think private cases are allowed to be public. Because in the
Sir,
last,
actually, after the evaluation of the
I don't think so
assignments.
because I don't think so I can do that because I'm not allowed to do that. I think so because even last year's assignment also the private cases were not given. Only the test cases were given. But whatever I was solving from the last year's assignment, it was private cases were not given. So I cannot provide you that.
So you'll be sharing the code, right, sir?
This code I will be sharing, of course.
Thank you, sir.
Will you explain briefly once again?
Okay. So first I am having I want to see the IJK pair. Okay, this is the crux of the code is here in this particular line. CTI is connected to CTJ by one intermediate of if there are direct flights from the IK and KJ. So what I am first doing is I am making a dictionary, key value dictionary, where I am searching for. I am having a dictionary where I will have from say CT2 where all the flights are going, from CT1 where all the flights are going, from CT3 where all the flights are going. Okay, that is one separate key value dictionary. Now in that I want to find my IJK pair. Someone is talking. Yeah. So in that this is my dictionary. Now in that I want to find where all the flights are going. Okay. So from 2 flights are going to 3, 4, 1 flight are going to 2, 3 like that. So now I am doing IJK. So this is my I. Now in each I, where all the flights from one I, where all the flights are going are my K. Now if now we have to find, see we have to find IK and KJ. That means K is the source. So sources are in the keys. So that's why I am writing if K is in flight.keys. So if 3 is any of our source, then we'll have a fight like 2, 3, then 3, 1. So between 2, 3 and 3, 1, so my IJK is now I is equal to 2, K is equal to 3 and J is equal to 1. So from so I have a flight like that from IK, that is from 2 to 3, and a KJ, that is from 3 to 2. Sorry, 3 to 1. Sorry, 3 to 1. So if my I not equal to j, that is not equal to 2. So if in case 2, 3, 2, if it that doesn't matter because 2, 2 is not, we are not interested. And ij is already not in the hop, so that it is not duplicated. Then I am appending the hop ij, that is I and some j. Say for example 2, 3, the j is equal to 3, 1, so j is equal to 1. So I am appending 2, 1. Lastly, I am just, since you have to sort it in a lexicographic order, so I'm just sorting it, sorted hop, and I'm returning that. This is the whole code. Okay, I hope it is clear. And okay, so finally now we'll move to the second. I'll share this particular quiz where the first one is already also solved, the first frequency code, and this one.
Before writing this, we have to import the data, sir.
Why
Flight
will
data.
you have to import the data? Because This one was from, this is not importing, right? This is just, we are just we have to just paste this particular code on the, that you had to. Now the
Yeah,
journey is over. You have to just, you had to just code this particular thing, and you can do it. You don't have to
good, good,
call
sir.
one of. This is just to show you that I have called.
Yeah. If you want to do in our editor, then
You
we
have
have
to
to.
just copy this particular thing, one of this.
Okay, sir.
And if you want to do in your own editor, just download this particular code and run it. The py file, download the py file and run it. Okay. Okay, we'll move to the week 6 quiz now. Okay. Uh, sorry. I'll have just little water. Okay. So we have 4 quiz here in our session thing. So quizzes are based on heap and set. Sorry. Sorry. Sorry again. Sets u and so suppose u and v both denote sets in Python. Under what condition we can guarantee u minus v minus u is equals to u? Okay. Sorry again. I have allergic tendency due to this rain. Sorry. Okay. So our goal is that u minus v minus u. Now minus, when it does, what does minus do? Someone tell me. If I do v minus u, what does it do? Come on.
The common will be shown.
Huh?
No, I forgot it.
See, tomorrow is your submission assignment submission date, right? Last date. Or today.
It removes all elements of U in whatever available in V.
Correct.
Yes.
Correct.
Elements of V which are not in U.
Correct. So v minus u is just whatever elements are whatever elements are whatever elements are not in what are in u but not in v. Sorry, whatever elements are what it removes whatever elements are in u but not in v. So so if I write something like this and make set denotation. So if it is my u, is my v. So v minus u removes, gives me only this part.
Yes.
Okay. Now I am doing u minus v minus u. So now you can see that at any point of time u and v will be a disjoint set. U and v will be u and v minus u. Sorry, u and v minus u will be a disjoint set, right? At any point, because I am removing whatever part that was in u from v. So u and v cannot have any common. Someone please stop. Close your mics. Please stop. Okay. So u and v will be always a disjoint set because this is my v. Okay. It's my v and this is my u. Okay. So u and v minus u are always disjoint because this particular only I'm considering this particular part. Okay. So u minus v minus u will be always equals to u because u and v minus u are a disjoint set. Now if you there are no common elements to remove. So u minus v minus u is basically u only because u again u minus v minus u removes any common element between u and v minus u. Since u and v minus u are two disjoint sets, so it is always u. So the correct answer would be this one. This is true for any u and v. Okay, it should be the correct answer. Okay, second one. Okay, suppose u and v denotes sets in Python. U union v not equal to u. I don't know what you should call it, but u cross v. What we can conclude about u and v. So these are all my options. Set u and v should overlap. Set u and v should be a subset. U should be a subset of v, and this is true for any u and v. Let's see. So let's see. So I have two sets u and v.
Sir, is that intersection?
Sir, can you please repeat
No,
the
this
question?
is. Sorry.
Can you please repeat the question?
Yeah, sure. Suppose u and v both denote sets in Python. U union v is not equal to. That is not. This is not intersection, right? Intersection is and. So this is this.
It's exclusive or sir.
It's exclusive. Correct. What? Just want tell me once more. Yes. Hello.
Yes, sir.
It's what you told.
Exclusive or sir.
Yeah, correct. So correct. So it's meaning that this will give you all the elements that has only once in u and v, that doesn't have, that is not any common element.
Yes.
Correct. Yeah. So
Yes, sir.
That is the only confusion. What actually that notation is telling, that u union v is not equal to u intersection v.
this is not intersection. This is the opposite of intersection. You can say that a subset of u intersection v rather.
It is u caret v.
Yeah.
Or-
Sorry. Yeah.
It is their exclusive.
Something like XOR.
So it's like I'll just write and I'll just draw and show you. If this is my u, this is my u and v, u and my v, then u, this the upper arrow v is this portion and this portion.
Yes.
Okay, this is just
Sir, okay,
u.
thank you so much. Yeah, got it.
Okay, and what is my u union v? U union v is, if we have a u and v like this, I know this u many of you know, but still uv, my intersection will union will be entire, this particular thing will be. Now the question is that when these two are not equal, now there are four options. First of all, is if u and v are two disjoint, so like this, then u common v is actually always equals to, right?
Equal, yes.
It will be equals to, so this doesn't work. So any u and v doesn't work. Then we have, say, if this is my u and this is my v, then also it is not working, because u union v is basically u, and u, this upper arrow v will be
The uncommon of u and v, which is not possible.
Because it is, again, and the opposite is also not possible. Okay.
U intersect v will be the answer.
Yeah, so again u will be the answer. So the only answer would be this, when u and v are two common. So in u, this u intersection v is this one, and u union v is this one. So these two are not equal. You have this part that is unequal. This particular part is unequal. This part is present in U union V, but this part is not present in U not equal to V. So our correct answer should be this one. U and V should overlap. Okay, so this is also a quite easy problems. Just all for the set problems, always just draw and do it. I feel it is very that at that time it becomes very easy whenever you draw. Even when I used to do in 11 12 sets, we used to draw and do, right? It's the same thing. Okay, so now we'll do the heap problem. So which one of the following does not correspond to a min heap on the list of values? This particular list. So what we have to do is, let's first copy this list, and okay, so what we have to do is we have to check if the list, if this part is on ascending order, because it's a min heap, so the root will be the minimum value, that is 19. Okay, so one easy thing to do is do like this. If 19, then from 19 to we'll have to jump like 72, then 72 to will have to jump from to 83, I think, and then 83 to, okay, let's draw it because it will be otherwise difficult.
Yes.
Yeah, so this is my heap. Okay, let's see if this is correct or not. Copy, and this is my, okay, I hope it is able to paste here. Yeah, so this is the one that is our first heap. Okay, let's draw it. So we have 19, then we have 28, 72, then we have 31, 29, then we have 87, 83, sorry, 83, 97, then we have 55, 45, and we have a 31 here. So here, if you continue from 19 to 28, it is all in ascending order. If you follow this part, it is also in ascending order. If you follow this part, ascending order. This part is also ascending order. This part is also ascending. So this is a correct heap. So it is not wrong. Okay. So then let's see what is the next. Okay. Let's see the next one. Then to copy this also, and okay, not getting pasted like that. Okay, so let's do this 19, and now we have 31, 28, 45, 31, 31, 97, 29, 72, 55, 83. Let's see. 19, 31, 45, 72. Okay, it's correct. Then 31, 31, 83. This is also correct. 45, 55. Correct. 19, 28, 29. This is also correct. 28, 97. So this is also our correct option. So this also you cannot see. Let's see the third one. So ideally you should do like that. You should apply the 2i plus j formula that was there in the video. That you have to see and see it like this. You have to go like hop like this and check. But this is the best option to do. Just draw it and see. 28, 29, 31, 31, 45, 55, 72, 83, 97. Let's see, 19, 28, 31, 72. Correct. 28, 31, 97. Correct. 3183 correct. 2945 correct. 2950 also correct. So we have solved, actually we have checked all three, so the fourth one will be the correct one, the wrong one. So fourth one will be the answer, but we'll just check it. So, let's see the 19 one. So last one, this will be the correct answer because other three are wrong, correct. So 28, 29, 31, 45, 83, 97, sorry, 83, 97, 55, 72, 31. So see, this one is wrong actually. This is correct, 28, 30, 19, 31, 55, but this is wrong, 28, 45, then we have a 31, so this is wrong. So this will be the correct answer, so fourth is the correct answer. Last question, so we have to do a delete mean. Let's see, consider the mean heap 19, 28, 31, 31, 29 like that. Suppose we apply operation delete mean to this mean heap, the resulting mean heap is this. You have also a question for like that had some typo error, that 98 point, that is not 98.79, there is 98 and 79, it will be comma. And remember, when you are submitting your assignment, make sure you give this curly brackets while giving. Because many people had complained last time that they got score. Make sure you give this curly bracket because it's a list. Okay.
Square brackets.
Square brackets.
Sorry, square bracket. My bad. Sorry, square bracket. Sorry, square bracket. So make sure you give the square bracket. Okay. So let's first draw the tip. Okay. So we have 19. From there we have 28, 31, 31, 29, 83, 83, 55, 97, 45, and lastly we have 72. Now I am deleting the mean, so this is I am deleting, so this I'll delete, and then also I have to move 72 to here. Okay. I have moved 72 to here. Now there is a problem here because you can see that 28, it's 72, 28, it's a minute. So between 28 and 31, 28 is minimum. So what will you do? We'll do 28, then 72. Between 72 and 29, so 72, that is again a problem. So between 31 and 29, 29 is smaller. So again we'll move 29 here and 72 here. So what is now, it's correct, 28, 29, 31, 97, it's correct, 29, 72. Here we didn't change anything, you don't have to check. So what will be our answer? 28, then 28, then to say
29.
Yeah, then 31, then again 31, then 72,
83,
55,
97, 45.
yeah. So
Please repeat this question, sir. Actually, like what values you interchange was little bit confusing.
okay, so okay, I'll repeat it once more. Let's just first check the answer. Which one was there? 28, 29, 31, 31. Okay, all of them has. Then 70 to 83.
Second option.
B is the
Second
answer.
option. Second option. Yeah, 70 to 83, 55, 97, 45. Okay.
72 is in the center.
Yeah, correct. Okay, so someone told that they didn't understand, so we'll just repeat it once more. Okay, so let's remove this. Let's once more draw the hip 19, okay, 28, 31, 31, 29, 83, 55, 97, 45, and 72. Okay, so I'm doing a delete. Sorry, I am doing a delete me. Okay, so I'm doing a delete mean here. So if I'm doing a delete mean, then I'm deleting 19, right? The minimum we are deleting. Now when minimum is deleted, we'll have an empty space. Now that empty space will be always filled by the from the right. So this is my right, which was the most right one, right? So then what I will do, I'll remove 19 here and put 72 here. Now we have a problem in the minimum hit, correct? Because 72 is greater than 28. Now how do you exchange? You check, sorry, in the next node, okay? You check in the next node whichever is smaller. So here my 28 is smaller. So what I'll do, I'll put 28 here and 72 here. Now we'll check in the next region. Yes, there is a problem. Now between 29 and 31, 29 is smaller. So what I'll do, I'll put 29 here and 72 here, correct? Now if we see, there is now between 72 there is no node. So now if we see the hip 29, 28, 29, 31, 97, correct? 29 to 72, correct? This we didn't change, so 31, 83, 31, 55. Now the interchange is clear. Now so we have to just write 28, then 29, 31, 31, then 31, 72, 83, 40, 55, and lastly 97 and 45. So this is how that means. Is it clear now? Hello?
Yes, sir. Yes, sir.
Oh,
It is clear.
okay. Okay, so then that's it for today. We'll meet again on the next week.
Sir,
Yeah.
sir, can you give some examples where this heap can be used in coding or something? Like where it is used mostly?
I have to check for the code actually. I don't have now any Python code, but I
Uh,
think that it will
Just
be
you
there.
can give an example like where this kind of thing is used in real life.
Okay, this real life example was there, right? This priority queues, what Sir has first told, like if you have say multiple jobs and you have a priority of jobs, so the
Okay,
job
the
with the
tree, right?
top priority would be here. So that we'll use max shift here there. The job will be with top priority. Say we rank our jobs. Okay, 1, 2, 3, 4. Now job with top priority will go at the top of the list. Then job with next priority will go in this part. Now if this job is done, we'll remove this job and we'll put whichever has higher priority. Like that.
Okay,
That
sir.
is the one
Understood.
example, one real life example you use. Priority
Thank
queue.
you, sir.
Okay. So for this is again this can be also used. So for example, in many times we have some selection, some any candidate selection, right? So we first choose the say the person which have some, say, some sports category, some rank, and some rank, which who has like some in study also. Now somewhere that person is not available, so we'll next go to the next person which have some study rank and sports rank, combine that whatever is there. It's like that. It's just prioritizing. Heaping means just you are prioritizing things based on maximum or minimum.
Okay, sir.
Okay.
सर आप एवरी ट्यूसडे 7 to 8 का मीट आप कंडक्ट करते हैं सर?
Yes, 7 to every Tuesday 7 to 8. But this is week 6, so we'll have 2 more weeks, week 7 and week 8, because it's a 8-week course.
सर वन मोर थिंग, जो प्रीवियस वाला आपका जो मीट का कहीं मिलेगा सर?
हाँ, it is there. If you go to the NPTEL if you go to the NPTEL here,
Yeah.
and yeah, so
Last.
you can at last you can see a problem solving session. Yeah, and yeah, if you view this problem solving session, you will find mine is like that, 7 to 8 p.m. or you can see this instructions for scholars. Here my name is Shobik. So all of this, the YouTube videos as well as the code is also present in the GitHub. So week 1 is like that, or for all the TAs it's in the list like this. So this is my YouTube link and the GitHub. Okay.
Okay,
You
sir.
can,
Because that one special problem, that one, I think TT ka, that I couldn't get, so I have to go back and
okay,
refer.
tennis. See, the thing is that here I solve and give only the previous year's assignment, not this year's assignment.
Okay.
So tennis one, yes, tennis one was little difficult. If the tennis if the deadline is over, I'll upload the assignment code.
Yes, sir. उसका deadline हो गया, but I would like to know, sir.
Sure, I'll upload it in the GitHub. You can see it there.
Yes, sir. Okay.
Okay, so I'll stop here now, and so we'll meet again next week. Thank you so much for joining. Goodbye.
Thank you, sir.
Thank you, sir.
Thank you.
No problem.
Thank you.
Thank you, sir. Good night.
Good night.